Question 7 from Section 1 of the 2019 National 5 Physics Examination. The weight of a robot on Earth is 240 newtons. The weight of the robot on Mars is, and you're given the 5 options as shown. Now, we know the key equation here from the data sheets is weight equals mg, where W stands for the weight, m is the mass of the object, and g is the gravitational field strength on the planet. So, we need to know the gravitational field strength on the Earth and on Mars, and we can find that by looking up our data sheet as follows. And now you can see Earth has got a gravitational field strength of 9.8 Newton per kilogram, and Mars has a gravitational field strength of 3.7 newtons per kilogram. So our first main point here is to work out the mass of the robot on the Earth, because remember, the mass does not change. So we start off with our equation, and our equation is weight equals mg, and if we divide by the g, gravitational field strength, we get the mass. A wee simple algebra manipulation there. So the weight on the planet Earth is 240, so we'll put that in, 240, divided by the gravitational field strength on the Earth, which is 9.8, and therefore we get an answer for the mass. And do that with a calculator and we get 24.5 kilograms. So the mass of that robot is 24.5 kilograms. Another key thing to know here is that the mass is constant. The mass of an object is constant. The weight can change if we take it to different planets. So all we have to do now then is use the gravitational field strength for Mars and work out the weight of the robot on Mars. So we do the same equation again. Weight equals mass times the gravitational field strength. And we now know the mass is 24.5 kilograms, and we know the gravitational field strength on the planet Mars is 3.7 newtons per kilogram. And you can see that the kilograms will cancel out, and we do the calculation, we get an answer of 91 newtons. So this robot has a weight on Mars of 91 newtons, and that will be answer C. Question 8 from Section 1 of the 2019 National 5 Physics Examination. A hairdryer is connected to a 230 volt supply. The current in a hairdryer is 2.0 amps. The electrical charge that passes through the hairdryer in 5 minutes is, and we're given our usual choices. Now the key equation here from the relationship sheet is Q equals IT. And we have to know what each of these symbols mean. We know that Q is the electric charge measured in coulombs, and that's what we're after. I is the electric current, and that's measured in amps, which we have got in the question. And finally, we have T standing for the time, which is measured in seconds. So we're looking for electric charge. It's a simple case of plugging in the numbers and calculating what Q is. So Q is going to equal to the current I times the time which the current's been flowing for. And we know the current is 2.0 amps, and we have to multiply that by the time. But be very careful, the time is given in minutes, and we have to convert that into seconds. So it's going to be 5 minutes times 60 is going to give us the number of seconds. So we work that out then, we get an answer of 600, and the units for charge is capital C, meaning coulombs. So therefore the charge flowing through that hairdryer in 5 minutes due to a current of 2.0 amps is 600 coulombs, and that is answer C. Question 9 from Section 1 of the 2019 National 5 Physics Examination. The graph shows how the resistance R of a thermistor varies with the temperature T. The thermistor is connected in a circuit at a temperature of 50 degrees Celsius. The current in the thermistor is 0.004 amps. At this temperature, the voltage across the thermistor is, and we're given our choices. Now take a close look at this graph. The graph is one of resistance measured in kiloohms and temperature measured in degrees Celsius. And as you can see, as the temperature in degrees Celsius increases, the resistance of the thermistor begins to decrease. Now we're asked to find the voltage across the thermistor, and to do that we have to use this equation here. V equals IR. Now we know what the usual symbols mean there. V is the voltage, that's measured in volts. We know I is the electric current, and that's measured in amps. And we know that R is the resistance, which is measured in ohms. So our first job then is to work out what the resistance of the thermistor is at 50 degrees Celsius. Now if you look close at the graph, 50 degrees Celsius goes up and meets the graph and then goes across, and it registers 2 kilo ohms. So right away I can work out the following. I know I'm going to use V equals IR. V is what I'm after. I know the value of the currents at that particular temperature. It's going to be 0.004 amps. And I've worked out the resistance of the thermistor from the graph to be 2 kilo ohms. Now 2 kilo ohms, 2.0 k ohms, we've got to be very careful, that's going to equal to 2000 ohms. So all we have to do is put the numbers in. V equals IR from our equation, and that's going to equal to the current 0.004 multiplied by 2000. Do that in a calculator and we end up with the answer of 8 volts. And 8 volts will give us an answer of D in the question, 9